This is Solve It for Kids.
Hello, my amazing and curious friends. My name is Jennifer, the Dean of all things STEM, and this is Solve It for Kids, the science podcast that gives kids and families a peek inside the real world of scientists, engineers, and experts as they solve problems in their jobs using creativity, cooperation, and critical thinking. And now please welcome to the show my podcast partner, Galactic Space Geek, Jeff Gagne.
Hello, Jennifer, and hello, listeners. I feel like we've had a lot of episodes that have sort of talked around this topic just a little bit, but today we are diving straight into it.
Yes, this is going to be so exciting. So what problem are we solving today?
Why should we connect science with art?
Why should we connect science and art? I agree with you that we have kind of talked around this, but I think this one asks why we should do this, which is really important. So who is our guest today, Jeff?
Our guest today is the right person to answer this question. We have Dr. Emily Rice. She is an associate professor of astrophysics at the Macaulay Honors College of the City University of New York.
Welcome to the show, Dr. Emily.
Hi, I'm so excited to be here.
Well, we are excited to have you, and we're going to talk about something that's near and dear to both of our hearts, especially Jeff, astrophysics, but also how it kind of intersects science and art together. I mean, wow, this is going to be such a cool talk. But I like to ask, okay, so as a kid, were you always looking up at the stars?
I wasn't, weirdly enough. I was definitely always a little bit of a nerd, I will admit. I always liked school. I was always good at school. I was best at math. And so I thought that I would do math in college and stuff like that. But I kind of learned the fun way that it's really cool to be good at the thing that you like, but you don't have to be good at the thing you like. And so what happened in college is I thought I was going to major in math. The first semester I signed up for a math class, and I also signed up for an astronomy class. And luckily that astronomy class was the intro class for majors. I'd heard about astronomy before, weirdly through one of my math classes. Right. But I was like, I don't know what it's going to be. And I loved it. And I did not like the math class as much. And so I went to my college advisor and I said, okay, I want to take the rest of these astronomy classes. What do I have to do? And they were like, well, you major in physics. And that's what the astronomy goes with. And I was like, okay, I can do that. Luckily I had taken physics in high school. I enjoyed that. I wasn't the best at it, but I enjoyed it. And I never thought, I want to be a scientist or I want to be a professor or anything like that. I just kind of kept going. I kept putting one foot in front of the other because I kept, I was interested in it and I did well enough at it that I wasn't discouraged or anything like that.
That's good. That's important. Yes.
Yeah.
Yes.
But it's very fun, it turns out.
Yeah, we think so.
Good. Okay, so sort of a double question really quickly. When you took that first astronomy course, were you taking it as just I think this one's going to be an easy elective. I'll get 3 of these science credits out of my way. And while you were in that course, can you remember what it was that caught your interest that you were like, whoa, I really like this?
Yeah. The answer to the first one is no. It was definitely something that I was interested in. And I even took the level up. There was different astronomy classes, but because I had the math background, I could take the intro astronomy class for majors and not the non-major kind of survey course. So that was definitely a happy, but I didn't really appreciate what the difference was. I didn't do that on purpose. I did what I could. And so that was just pure luck. And then what was interested in it, it was kind of everything. It was definitely a survey course of everything from the night sky and how it moved and how it changed to stars and nebulae and galaxies and kind of the universe as a whole. And everything was so new to me that everything really blew my mind. And so I wanted more and I wanted more. And then it got, more technical from that and more kind of detailed. But that first one
Yeah.
really whet my appetite for everything. Yeah.
Well,
When you start learning space, it literally just keeps going and going.
Yeah.
There's
And
more to
it's
learn.
expanding. And so there's always going to be more to learn. Yeah.
Well, if you look up what you're doing now, you're kind of working with brown dwarfs. I had to look up what those were. Could you tell us what a brown dwarf is and why it's important and why you're studying it?
Yeah, so brown dwarfs are these objects that like most people have probably never heard of, and that's okay because they're not like things that we can see in the night sky really easily.
Oh, okay.
They're also not very photogenic. They're not like a galaxy or a nebula that's very photogenic. But brown dwarfs are still very important because they're these things that we usually talk about them as in between stars and planets. Not really physically, but like in terms of their properties. And so we have stars in the night sky, stars like the sun, but stars actually have a range of properties from 100 times the mass of the sun, for example.
Right.
And then much smaller than the sun as well. And then planets also have a range of properties, like from big planets like Jupiter and Saturn to little rocky planets like Earth and everything. But it turns out that planets actually get much more massive than that, bigger than the planets in our solar system. And stars also get much smaller. And kind of in between those two things are these brown dwarfs.
Okay.
Yeah.
So why do we care about them? I mean, just because they're out there? I mean, that's what I'm just wondering.
A little bit of that, honestly, like a little bit of like they're there, they're part of space. And so we want to understand them as astronomers, but also because it helps us tell the full picture of star formation, for example. So why stars form at all of these different masses, how many of them form at different masses. And so we also try to figure out, what's out there. And it turns out that there's higher numbers of the low mass stars. Which is kind of weird if you think about it. Yeah, the high mass stars, there's just a handful of them. And those actually have shorter lifetimes too. And the lower mass stars also survive. It's weird words that we use for it, but they last a lot longer. And so these low mass stars can create their own energy for billions of years.
Wow.
But brown dwarfs are actually like what makes a brown dwarf and not a star is that it doesn't create its own energy like a star does. So it forms like a star does from a collapsing cloud of gas and dust and kind of becomes smaller and denser and circular or spherical. But then a star will reach a high enough temperature at its core to ignite nuclear fusion and fuse hydrogen into helium, create its own energy. But a brown dwarf doesn't quite do that.
So that kind of helps you connect, like you said, how these form, because it's kind of like the middle spot.
Yeah, it's kind of like the middle spot. It forms, but it doesn't create its own energy. It doesn't become fully stable and radiating like a star does. But the brown dwarf will kind of cool and fade with time.
Okay, wow. My mind's blown. I did not know that.
Jeff, you know these things were out there, right?
Jeff probably knew that, but I did not know that.
That's why we have this podcast.
Yeah.
So with brown dwarfs, and that was a great explanation of how they don't create their own energy.
Yeah.
Can you describe for all of us a little bit more on the other end of if they don't create their own energy, why aren't they just considered big planets?
Yeah.
What gives them their own category?
They end up being similar to planets in a weird way. So because they don't create their own energy, they kind of cool and fade with time, and they get really cool, especially in their outer layers. And so they start to have molecules in their atmospheres, where stars like the sun are usually too hot for molecules to form. They start having what we call dust in astronomy, which is small solid particles. They have clouds, like clumps of this dust and clumps of water vapor or methane or ammonia or things like that. It ends up that they start to resemble planets, both when they're old and when the brown dwarfs are lower mass. But planets are going to be different in terms of formation. So planets form in disks around stars.
Right.
And the idea is that brown dwarfs form on their own like a star did. Or like a star does. Yeah.
Oh my gosh.
Later on, we actually have a harder time telling the difference between the two because you can have a really high mass planet that's
Right.
maybe 20 or 30
Right.
times the mass of Jupiter. And you can have a brown dwarf that we think formed on its own out in space and might be 5 or 10 or 20 times the mass of Jupiter. And so some of their
Wow.
properties will overlap, but we think that their formation should have been different in the past. Should have been, because we don't
Okay.
really know. It's still very hard to tell for sure. And so the cool thing is about brown dwarfs is that we've only known about them for a handful of decades. And so we're still trying to make the observations and kind of put the pieces together to tell their full story, which is very, very cool. Like, it's very much still a discovery space for a new type of astronomical object, which is, I never would have thought that I would study something like this when I was in college.
Yeah. So how did you land on studying brown dwarfs?
Yeah, when I started grad school, that was like the advisor that I talked to. I really picked it through my advisor.
Okay.
I met with a bunch of people at UCLA, and the person that I thought was kind of the nicest and the most supportive was also the head of the instrumentation lab, which I also thought was really cool. So he built instruments to go on telescopes.
Oh, wow.
And, new technology and new techniques for doing new and different types of observations, which I thought was very cool and very closely related to engineering and things like that. And his next big instrument was particularly focused on collecting the light in a certain way that would be best for studying these brown dwarfs. And so he was kind of new to the field because he had studied different things in the past. The instrument that he was building was like, here's a new area of observation that this opens up.
That's
and so
cool.
Let's do something that nobody else has done before. And I was like, yeah, that sounds awesome.
I'm on board, right? Yeah, I'll do that. That sounds really cool.
Yes. For the fact that there is, we already mentioned, so much out there in space, literally everything, being able to make new discoveries it really does pique people's interest, to include, I think, brown dwarfs have gotten a recent boost in just the general public, because didn't they just point the James Webb Space Telescope recently at a brown dwarf, and there's now a new artist rendering out there?
Yeah. One of those really cool results is actually by my colleague at the American Museum of Natural History. So I'm in New York City, and I teach at the City University of New York, but I also have a research associate position at the American Museum of Natural History, which is very, very cool. Yeah,
it is. I've been there. I've been there. It's very amazing.
It is an amazing place to be an astronomer. I actually give tours all the time for friends and things like that. Yeah, that's very much, unofficial, but I love it, and I love sharing it with people.
Very cool.
One of the great things about the JWST is that it's optimized for really long wavelengths of light and really highly sensitive, which these brown dwarfs are very, very cool because they're so low mass and so low temperature. Most of the light that they emit is at these long wavelengths of light that we can't really see with our eyes.
Wow.
And so JWST is just one of the most sensitive infrared space telescopes we've ever had. And it's really ideal for looking at these brown dwarfs. And so we're at the point where we can't even fully interpret the data from it yet, because our models aren't good enough.
Wow.
The models are very complex, and trying to put together what we think the atmosphere is going to be like, and the chemistry and the outer layers and things like that. But the data is just also so rich and so high quality that any kind of small mismatches gets amplified.
Wow.
Yeah.
Well,
wow.
So I think this is a good place to kind of segue into, how does science connect with art? Because we've talked all about brown dwarfs, but how can we kind of put art with that?
Yeah. The way that it first came across my kind of awareness was through the brown dwarfs and through these beautiful artist impressions, artist interpretations that we have. Because the thing about these brown dwarfs is that we can't see them like we see planets, especially the planets in our solar system. We have these gorgeous images of Jupiter and of Saturn and rings and cloud layers and things like that. But the brown dwarfs are much more like stars. They're so far away that they're always going to be these tiny points of light.
Okay.
And sometimes we can do a little bit more detailed observations and try to map the surface
Right.
of them and see, okay, are there temperature differences? Do things get brighter and darker because of something going on, spots like the sun has, or clouds or something like that? But we're always kind of guessing at that. And so what the artists do is create these kind of beautifully detailed impressions of what we think they could look like based on our understanding of them and based on what the planets look like. And those have always been so special to me. Like I always start talks with them and I always reference them and things like that. And it's like, they're definitely based in what we think we understand about them, but they're also so beautiful and so pretty. And that's one of the reasons that I like them, is it gives us something to kind of hold on to a little bit more.
And so I think too, when you make things visual for people, doesn't that kind of involve them and invest them in it and make them feel like, ooh, this is really cool, right? And they can kind of see it because they can now see it and imagine it in their heads.
Yeah, especially in like a relatable way. So this also, it affected the way that I dressed, weirdly enough. And so when I was giving public talks or planetarium shows or something like that, I was always looking for things that had astronomy themes on clothing, skirts and leggings and things like that. And it turned out that other astronomers were doing that as well. But in one of them in particular is Summer Ash, who was director of outreach in the Columbia University about 10 years ago. And we overlapped and we met maybe at the Intrepid, even Air and Sea and Space Museum, which is another very, very cool museum in New York City. And we both realized that we loved wearing these astronomy themed things, but we both had New York City closets, New York City budgets, which is the same like zero. And so we said, wouldn't it be fun to start a blog where we can find these things, like kind of write about the things that we find, and share them with the public, but we don't have to buy everything ourselves. And long story short, that has become one of my big projects. It's called Startorialist, and it backfired amazingly because it's now a shop.
Oh my gosh. Okay. Yeah. You said things you didn't have to sell or whatever. Okay.
Yeah, things we didn't have to buy ourselves, but now it's like my entire closet is space clothes because I get the samples and things like that. But it turns out like there was so much more to it than we ever expected, especially in terms of taking these beautiful space images, the artistic representations, like changing things a little bit. One of the first things that I kind of collaborated on myself was a woman was doing space and science themed clothing. And so not just space, but also like, leggings with the periodic table on it. And the periodic table would be brightly colored squares. And
that
so
sounds,
it's like,
I'd be up for that. Yes.
Yeah. It's beautiful, beautiful stuff. Night sky dresses, neurons and things like that. All these things that are very sciencey, but like you can also make them very aesthetically interesting and wearable and things like that. And I wanted a particular dress that I said, look, there's this beautiful Hubble Space Telescope image of Jupiter that shows its cloud bands.
Yes, I love that one. That's my favorite.
I took it. I said, but I love this on a dress, but can you make it purple?
Ooh. And that would make it very pretty. No, that would make it very pretty.
But also because the brown dwarfs, like sometimes we think of them as, because they're hotter than Jupiter, they're going to kind of glow a little bit more reddish magenta. And that's usually what we had put into their artistic representations. And so I wanted a purple Jupiter dress to represent the brown dwarf. And she made it and I loved it. And it's one of my favorite dresses. And she was also doing things with, when the new image of Pluto came out, for example.
Yes.
Which that's an interesting, that's a before and after for me. Like before this New Horizons flyby, we did not know what Pluto looked like. And now we have this beautiful image of Pluto, and a bunch of astronomers and planetary scientists were like, I want to wear it. And so some of our collaborators made dresses from it. Like, it's such a, Summer and I weren't the only ones that were very interested in it. And that there had been other people doing it. Like Neil Tyson famously had his celestial themed vest and things like that. Right. But we definitely I joke that we became the dark energy in the expansion of the astro fashion universe.
Oh my gosh, that's a great line.
It's very, very nerdy.
That's a great line.
But we really did. We kind of picked up on this trend and just fostered the excitement for it among our colleagues. we thought it was for the public. Like we thought the blog was for the public.
Right.
And then when we presented the blog at research conferences, because we could do that, there was always poster sessions for
Right.
education, for
Yeah.
outreach projects and things
Yeah.
like that. The astronomers were just so excited about it. Like they were more
How
excited
can
about
I
it
get
even
a
than the public
t-shirt?
were.
See,
Yeah, exactly.
Some people want t-shirts about Taylor Swift, and she is amazing. Don't get me wrong. But those of us that are science geeks, we want t-shirts and dresses of astrophysics,
and
planets, and
sometimes
brown
we do
dwarfs.
both. Yeah.
And sometimes both. There you go.
Yeah. So for the eclipse, so Startorialist, because it was so popular with the astronomers, we did pop-up shops at the research conferences.
Oh, wow.
And then because
Nice.
it was still so popular, we started an online shop in 2020. And funnily enough, that one of the things that we did recently was the eclipse was coming up, and I was like, what do I do? What do I do? What should I design for the eclipse? And a friend of mine who's an amateur astronomer and amazing was wearing a Taylor Swift t-shirt that said, a lot going on right now.
Oh,
Right? Because she had
good.
she had the not a
Yep.
lot going on, then she had a lot going on. And I looked at it and she was like, yeah, I've got a lot going on because I'm getting ready to teach about this eclipse. But I was like, those letters are also in the word totality. And so I made a t-shirt that said totality going on
Whoa.
at the moment. And
Oh,
those are
that's
very
brilliant.
popular. And a bunch of people wore them during the eclipse. And just, these overlaps. Another
Yes.
big one was when Nathan Chen, this is the Winter Olympics a few years ago, and the figure skater Nathan Chen
Yes.
had worn some spacey themed, like he had a Star Trek kind of type top, and he wore one at the
Yep.
Winter Olympics that looked very spacey, but it was also kind of this wacky color palette, like purple and orange and red and yellow. But astronomers saw it and looked at it and were like, that's a real space image, like a real telescope image.
Wow.
And they tracked it down. Yeah, they recognized like the pattern in the nebula. They recognized
Oh my
Right.
God,
the
that's
shapes of the
hilarious.
stars can tell you what telescope it came from. So we found the image. I had my graphic designer recreate kind of the color palette, and we made a version of that shirt.
Wow.
And then we made it as a dress, and we made it as a skater dress and a skater skirt. And that, like, I found posts about it on like figure skating forums,
That's fantastic.
which I thought was really
Nice.
fun. That like there's these overlaps of like space and it doesn't have to
It
be
should
just
be.
the nerds
No.
and not just
No.
the science, but also the aesthetics of it and how it gets worn and used in popular culture. And
Yeah.
it's just so cool to expand
Sure.
everything like that.
Yes.
And even in the science, we're always making creative choices. Like we don't
Yes.
realize it, but like you guys
Yes.
said in your intro, it is creativity. There's critical thinking, but there's also creativity. And I think we can do kind of both things. Like we can add the science into the art. And also you don't have to be good at it. Like you can learn
Yes.
as well.
Yes.
There's graphic designers, there's techniques, there's all kinds of approaches that you can learn, but also incorporate the art into the science and kind of take both of them seriously at the same time. You really, really can.
Right.
And it's a very fun way to collaborate with people with different backgrounds and different approaches and different areas of expertise and different skills and different talents. It also makes me feel much better about being a scientist because I think science growing up was always like, oh, I got the answer in the back of the book. I'm right. Good. And you felt like a smart kid. Like that's,
Yes.
that's why math appealed to me. I fully admit it's
Check
because I
done.
could get the answer and I was a
Yes.
smart kid. But now it's like, okay, scientific research is when we don't know the answer in the back of the book. And it's actually,
Exactly.
there's a lot of excitement about the discovery and things like that, but we don't know what the answer is. We don't have a reference to check necessarily. And so it's like
Right.
part of the problem is figuring out how certain we are about the answer. Not even
Yeah.
what the answer is, but how well do we think we know that answer? And
Mhm.
even that can be very open to interpretation. And I feel like that kind of uncertainty or the more kind of subjective or that approach is kind of much more intuitive in arts where like you don't have to be good at everything. You can learn, you specialize in a particular thing,
Right.
maybe because it just strikes your fancy. Whereas in science, it's like, okay, everybody has to be able to do this and everybody has to be able to do this. And it's not necessarily the case. Like you can pick one thing that you're good at and something else that you always find a collaborator for, because
Yeah.
that's not something that you want to spend a lot of time working on or anything like that.
Right.
And
Right.
and so in art, you can focus on the medium or the materials or the the technique or something like that. And that's your niche, and you can be comfortable in just that, and kind of borrowing from these different approaches between science and art, I think can really make both of them even more fun and even more interesting.
Yeah, well, and
Agreed.
and more accessible to everybody. I
Yeah.
think sometimes people look at science and they're like, "Oh, I'm not a scientist. I don't understand that," and all this kind of stuff. And this is what I do when I go talk to do school visits, is I talk about how the science is all around you.
Yeah.
Like everything you see, the lights, the computers, the rug was made from science, right? And so wearing the art or seeing art, I think opens it up to a bunch more people, and getting them maybe feeling more comfortable with science, right? Because some
Yeah.
people are kind
Yeah.
of like, oh, science, I don't know. That's physics and woo, that's above me. No, look at can you appreciate the beautiful pictures of, Jupiter, the one from James Webb? That's like my favorite. Like I've
Oh,
never
yeah,
seen
yeah, yeah.
Jupiter like that before. And
Yeah.
I just stood in front of this. We went to an exhibit and it was just images of the James Webb Space Telescope. So it was like you're in an art museum, right?
Yeah. You can get
And I was
lost in
just
some of those
right. I
images.
was just
Yeah.
standing in front, and they had blown it up really huge, right? And I was like, wow. And that would never have happened if it just a scientist had created it. An artist had to
Yeah.
step in and make it that kind of beautiful. So I think that's
Yeah.
really cool, and that's important what you guys do for all of that. Is there a favorite dress or shirt or something that you have?
I couldn't pick one. I absolutely couldn't pick one. But we do have a handful of designs that are very much this collaboration between the science and the artwork.
That's fantastic.
And those are really my favorites. And when really the artists become like part of our community, or when the
Right.
scientists themselves are creating artwork, like that's also amazing too.
Yeah.
A lot of people are like, I don't have the talents for it, but a bunch of scientists do have the talents for it. And one in particular, I'll pick a recent favorite, is this one, because it's based on an actual stained glass piece. So it's two astronomers who were working at the Space Telescope Science Institute in Baltimore. One of them was learning how to do stained glass, and so he kind of asked her to do the design, and so she laid it out, and he made it in stained glass. And now, so the original of this actually hangs in the lobby of the building in Baltimore, Maryland. It's David Law is the astronomer who made the stained glass, and then Nora Lutzendorf, I think, did the design for him. And I was like, this is so beautiful. And everybody that goes to the building takes a picture of it. Like, can I license it from you and make it purchasable so that, we can, more people can share it, basically. And I did have to so I had my graphic designer then kind of recolor Nora's original plan to match how the stained glass turned out. And so it kind of came full circle.
That's
With
gorgeous.
4 really different, like, scientists, artists, designers collaborating to make this piece like that. And I put it on notebooks. I have a pillow in my room. We've put it on, what else have we put it on? Oh, like mugs and things like that, so that it's so wonderful to hold this thing and think about how much work and thought and creativity went into it to kind of pay tribute to. So it's the JWST mirror, but also in this kind of rainbow from red to blue. And then also the original is called Web Rising, and then I call it JWST Rising for our kind of digital version of it.
That's beautiful. That's
Yeah,
beautiful.
it's very, very fun. But so many.
Yeah, so we will have a picture of that on our website so everybody can check that out. It's like a half of the James Webb Space Telescope mirror image. Okay, so we have come to the point in our show, although we've had lots of fun. We talked about brown dwarfs, we talked about science and art and all these different things. But I'm curious, Dr. Emily, what challenge do you have for our listeners?
I am going to challenge your listeners to be creative with science. And so what I want you to do is go to an image gallery from a space telescope is one of the easier ones, but there's also image galleries for ground-based telescopes. So you can go to webtelescope.org or the JPL Photo Journal, or the Chandra X-ray Telescope also has some amazing images, or ESO, the European Southern Observatory. Find an observatory or a space telescope, go to their image gallery, scroll through it, and find something that strikes your fancy. even just based on the colors or the composition or something like that. Read about the image and then design something to go, that image to go on. So how would you like, would you wear it on a dress? Would you wear it on a shirt? Do you want it hanging on your wall? Do you want it as a phone case? Do you want it as on a scooter or on a car or something like that? Like, let your imagination run free, but take these space images, bring them down to Earth, and create with them.
Oh, I love that. I love
like
that.
It.
Yeah.
It's like a kickstart for creativity.
It really is. The universe gives us so much
You get the beauty from that space image, but then that's going to spark something else.
Yeah.
Yes.
Yeah.
Yes, absolutely. Oh my gosh. Well, this has been such an exciting episode.
It has been great.
Thank you so much for being on Solve It for Kids, Dr. Emily.
Thanks for having me. So great to talk with you.
What a fun episode, and really delving into why science and art go together. And when you start talking about it and you bring up some of those examples, you realize just how much science and art are already together out there in the world. We just may not be paying direct attention to it.
Yes, and the thing is I love that she's creative with it, because science can be scary for some people. Oh my gosh, I have to know this. But when you see it, it's all around you, as I say all the time. You look everywhere and there's science, and you can be creative with it. So I love some of her ideas. And also, I love the challenge, because any excuse to go look at the image gallery of some of these amazing telescopes, I'm up for that. I know you probably are too, right, Jeff?
Oh, definitely. Especially some of the examples she gave. That challenge is to find a space webpage. Kids, make sure it's okay with mom and dad, but the Webb telescope pages for James Webb Space Telescope, the Jet Propulsion Lab, JPL in California, the Chandra X-ray telescope, all of them have amazing images. And then her challenge is to create or design something out of that space image. And she gave a bunch of examples, like make clothes, make a coffee cup, make some sort of wall art. And then the cool thing about this challenge is it is open to your entire imagination. Whatever you can think of, we just want to see it after you create it.
Yeah, that would be amazing. We would love to see anything that you create, as would Dr. Emily, because we would send it to her. So if you come up with something really cool, you can share it with us on social media. We are at KidsSolve at Facebook, X, and Instagram. And don't forget to check out our website, solveitforkids.com, where you can actually email us your images if you prefer, but you can find out tons of information about this episode and all of the other episodes, and including some really cool stuff from Startorialist, which Dr. Emily created, will be right there on our website. So go and take a look.
You guys be taking a look at all of that stuff. Create your own. Jennifer and I are each going to pick a favorite space image from one of these websites as well, and share that in our social media.
Yes.
Until next time, you'll hear Jen and Jeff on the Science Podcast for Kids and Families. Solve It for Kids.